So here's the set of people in this room, right? Now, and so the empty set is just a set with nothing in it, right? So now, so let's just call the empty set 0. Okay, we'll just call it that. Now, there's another set that this set has one thing in it. You know what's in it? The empty set. Okay? So this set contains the empty set in it. This is not the empty set because it has something in it, right? This is in it. Of course, this has nothing in it, but whatever, right? So this is the set containing the empty set. We're going to call that 1, because we can. We can call it Brian if we want. We can call it spaghetti, but we're going to call it 1. Okay? The set containing this set and this set, we're going to call that 2. And notice, how many things are in this set?
1.
How many things are in this set?
2.
Now, the set, then we can make up another set that contains this set and this set and that set. Okay? So this set contains how many things? 3. So we can just keep creating numbers this way, right? We can even create addition by saying that if you have one set, let's say this one and this one, or let's say you have one set, you can add it to another set. That just means you're going to make a set that has all of this, that has this one in it and this one in it. So that means that we're just defining this. It doesn't mean anything. We're just making this up, right? That 1 plus 2, that this is the set that contains this, and the set that contains this. Okay? Now, this, let's see here. And somehow empty set. I'm forgetting something because for some reason I've defined addition wrong because for some reason I'm also supposed to have the empty set in. So maybe we need to define addition as the empty set, as a set that has the empty set in it and the 2 things we're adding. Because in that case, what we end up with is we have this set here by adding 1 and 2, right? Yeah. Oh, no, we don't have to make that special rule. Sorry. Addition will be defined as everything in this set and everything in this set. So what's in this set is the empty set. What's in this set is that, and then the empty set again. That's okay though, we can have 2 copies of itself, it's fine. And this has 3 things in it. So 1 plus 2 is 3. I think that's right. I'll have to check up on this again. There's a YouTube video that explains it much nicer than but what's cool about this is you can get all of the natural numbers, right? All of the whole numbers, just from literally from a set with nothing in it. Like we still have nothing, right? But we've created all of the numbers.
But this thing is that the nothing was enveloped with something.
By something. Right, this was enveloped by something.
The problem with this is that you're assuming that there's already something to consume the nothingness. So
nothing,
and it's
something
automatic processes even if you
which is still
even if
nothing,
you had
but
all
it
of
makes
this,
something.
Yeah, but then like all of a sudden you like spontaneously have something to envelop.
So your problem isn't with the nothing.
It's zero
Your
reception.
problem is with the circle around the
It's
nothing.
nothing.
Yeah,
that's within something. Within something.
Yeah.
That
And
means
then
nothing.
all of a
But
sudden
it still
something
makes
spontaneously
something.
Envelops the nothing.
Right. Well,
You're assuming that
Ryan,
that there's
I'm
something
showing
there to
Tito.
envelop it.
Join the
Well,
team.
we're creating it
And Commander, most likely.
because we are allowed, when we're talking about sets, we're like, there's no reason why we can't just say, like, we can just make sets up, right? Like I was doing about the sets of people in the room.
Yeah.
Like I can just say that's a set, and then I can say, well, here's another set that is the set that has in it the set of all the people in the room, right? Like, we can just make sets up as all day long. And I don't know that we have to assume, I mean, this gets into basically whether or not, I think ultimately, like philosophically, it gets into, is it okay for us to create meaning, I guess. Like, is it okay for us to like decide that things have meaning? Because if that's not okay, if we don't generate meaning of like language and ideas, then we can't actually say that there are these sets here. But if we're allowed to like have ideas that mean something, then I think it's okay for us to say that we have sets of nothing at all. Because we're allowed to say it. We're allowed to think it. It doesn't matter that we have no, like, we don't, like, these are just pure figments of my imagination, or of our imagination, right? Like, we don't have to assume that they have any basis in reality at all. Right? Is that sound reasonable, or is that not?
Yeah.
Okay. I mean, I think that's a pretty fundamental problem, that like, you have to decide, I guess, whether it's okay for us to make things up.
Sort of like relative morality or something like that?
I think that maybe is an application of it. But that, I feel like morality is a whole more complicated thing. Like, this is very simple. Like, this is I'm just talking, and this is one of the things, this is what, like, why this sort of area or region of mathematics is called fundamentals, is because it's stripping away so much, so that all we're really talking about is some very, very basic sort of logical structures. It's really getting at the logical structure of thought and idea and meaning. That's why, like, that's why for me, what turned me on to math was that these logic classes that I took in college, was because that was when I first started realizing that like all of the math that we normally do, like the calculations and stuff, that there's this thing under it that's solid. And it's solid precisely because, and this is sort of a silly thing to say, but it's solid precisely because we agree as mathematicians or as people that these symbols here, 1, 2, 3, plus, equals, that they're all meaningless, right? These are just meaningless symbols, and we've invented these rules about how we've chosen to move the symbols around. And it doesn't matter whether they apply to anything or not. And this is one of the amazing things to me about math, is that, like, it doesn't matter mathematically that, I mean, just as an example, that like are you familiar with the Pythagorean theorem?
Yeah.
It, like, the whole idea that, and I mean, I don't really like this way of writing it, but this sort of thing, right? It doesn't matter that this actually does happen to describe the way triangles look and behave in the real world. Like, this whole thing, this whole relationship about triangles, or right triangles specifically, and their sides, is true regardless of whether or not reality agrees with it, right?
And it's thus a law, like gravity or thermodynamics.
Yeah, well, with gravity and thermodynamics, what's amazing about them is that they're so, like with gravity, I just think it's amazing how mathematically elegant the whole thing is. I mean, Newtonian gravity, like quantum gravity and stuff gets, like, I don't understand any of that, honestly. And, you know, I would like to, but the math is way, way, way over my head. You know, with, like, I think it's amazing. There's a quote by Carl Sagan that, that it's, and I mean, you know, obviously Carl Sagan was a fan of evolution, which is part of where this discussion began, right? But
Yeah, he was an agnostic.
right. There's this quote of Carl Sagan that I find it elevating and exhilarating that evolution permits the universe permits the evolution of molecular machines as intricate and subtle as we. That I find it amazing that these mathematical laws that really don't necessarily have anything to do with reality actually seem to have something to do with reality. I mean, that's kind of incredible that math and science and the natural world actually seem to be connected to each other. Like that, to me, that's amazing. I don't know.
So Carl Sagan was basically talking about like biochemistry, how like molecular systems evolve.
Yeah, like he was talking about how it's pretty incredible just that the laws of the universe, the physical laws, allow the evolution of these things. And really, I mean, I'm just a sack of water and salt and a little bit of other stuff. Yet I have feelings and I think about things and we can talk to each other. And when you think about what is physically happening right now, like, I mean, I just have this like little slab of meat here that's going and like I'm pushing air out with this other muscle, right? And it's making sound waves emanating out that somehow are you know, like they go into your ear and they get processed into electrical biochemical and electrical signals that do things in your brain, and the patterns of electricity and chemicals in your brain somehow translate into an experience of meaning to you, so that somehow we can say that you understand the words coming out of my mouth is just kind of mind-blowing to me, right?
Yeah, but what I see is that I was reading this book, right?
Yeah. You can here's an eraser for next space.
Are you familiar with the with irreducible complexity?
No, never. I've never heard that term. I know what the words mean, but.
So basically, I was reading this book and it gives you the example of blood clotting.
Mm-hmm.
I'm just gonna name a few off the top of my head.
Yeah.
There's these factors on